mowing next door, so I'm hoping that you can hear me. I also have multiple cats trying to jump on me, so I apologize if you hear that all in the background. So we're going to do the first section of notes for chapter 16 in the reproductive system, and we're going to talk about male anatomy and essentially male physiology, which includes sperm production and testosterone production. Interesting thing about the reproductive system is that it's an optional system. We do not have to use it. Now, as an entire species, we have to use it, to continue our species, but it's one of those, optional things that you do not have to use no matter what anybody tells you. All right. So the reproductive system, basically the function is to produce viable offspring. This system is going to essentially slumber. I like this word. Slumber. Oops. Let me get my thing here. So if I have this, I want a pen. Ooh, here we go. It slumbers until puberty. So, humans are born with their reproductive anatomy physiology. However, nothing's happening with it because it doesn't have the hormones derived from the endocrine system to turn it on. The primary sex organs for males are testes and females are the ovaries. The testes and the ovaries are much like the pancreas in that they have both an endocrine and an exocrine function. So their endocrine function is to produce hormones, and their exocrine function is to produce sex cells or gametes by way of egg and sperm. So here's a cross-section of the female and male reproductive system. So the male sex organs are the testes. The testes are aided by what's called a duct system, which is essentially a system of tubes that assist the testes in getting their product, which is sperm, as close to the egg as possible. And again, the testes have two functions. Their exocrine function is to produce sperm. Exocrine means that you have something made within the cells or within a structure, and then it gets pushed to an apical surface or a free surface. So where sperm get made, there's this kind of tube like this. And sperm are made in the wall of this tube, and they get pushed into an opening or lumen, as you all know. And then after they're created, they get pushed through the lumen of the various duct system outside of the body. The endocrine function, so hormone function, is to produce testosterone. And that testosterone production doesn't happen until puberty, all right? So there's a cascade of hormones that happen that start up in the brain. So the hypothalamus produces what's called GnRH, which is gonadotropin-releasing hormone, which affects the anterior pituitary, which then produces, as we know, two gonadotropic hormones, FSH and LH. And then FSH and LH are then going to target either the testes and ovaries for them to produce their hormones and start to develop gametes, i.e. sperm or egg. So here's a cross section. I'm going to change my pen color here, which you can probably see. Let's see, I'll change it to blue. So here is the cross section of the male reproductive anatomy. So here are the testes, where sperm are produced. Testes sit on the outside of the body in the scrotal sac, which is there for a reason. These are the actual testes where sperm are produced. This structure, which I know kind of looks like a slug or a worm, is the epididymis. This is where sperm actually go through a maturation process called spermiogenesis, and where they are stored until ejaculation occurs. Once ejaculation occurs, sperm come out of the epididymis, go through the duct system. This is the vas deferens. They literally go up and over the bladder, which is crazy. They go down the back of the bladder, and at the back of the bladder or posterior aspect of the bladder, this is where the right and left vas deferens are going to converge and come together. They are then going to form the urethra. The urethra goes through the prostate glands. Then we have this quick membranous urethra, and then we have what we talk about in the urinary system, the penile urethra, sperm to come out the body. That is one crazy loop to loop. And I like to think about why we think guys are thrill seekers. Look at what sperm do. They literally have a roller coaster ride to come out of the body, which is kind of crazy. So again, penis, bladder, testes, vas or duct deferens. This here is the prostate gland, which sits underneath the bladder that we talked about last chapter. All right, testicular anatomy. All right, so the testes are about 1.5 inches long and about 1 inch wide. And they are surrounded by a connective tissue, which is called the tunica albuginea. Outside of the tunica albuginea, there is another tunic layer called the tunica vaginalis. But the albuginea, I don't know if you've heard the word albino, which means white. So this white connective tissue capsule surrounds the testis itself for protection, but then pieces of the tunica albuginea actually come in to the testis, kind of like what we learned about with the lymph node, and it separates the testis into lobes or lobules. Okay, there's about 250 lobules, which we actually call septa. So if here is, the testis, sorry, I'm with my mouse finger here, then you have the tunica albuginea that comes in like this and kind of creates walls that separates the testes into little lobes that we call septa. Those would be the individual septa. Inside the septa, so inside each one of these, you have 1 to 4 seminiferous tubules. Seminiferous tubules look like ramen noodles, I'm not going to lie. And the seminiferous tubules are the sperm factories. So if they're tubes, we know that they, are going to look like this. So they're going to have an open lumen and a wall. And it's the wall here where the sperm are actually being produced. So this would be a testis. This would be the tunica albuginea coming in and separating testes into a bunch of lobules. And then within each one of these lobules, let me change color here, you will have 1 to 4 seminiferous tubules, which look like little ramen noodles hanging out here, like this. Makes, more sense on other pages. But so seminiferous tubules are factories. That's where sperm are produced. After the seminiferous tubules, sperm onto an area called the retestis. The retestis is responsible for removing excess water from sperm or semen. If semen is too dilute, meaning that there's too much excess water, then sperm will not come into contact with the fluid, the seminal fluid that they're bathed in. And that seminal fluid actually has nutrients, activation particles in it, pH buffers, that the semen need. But if it's too dilute, if it's too watered down, sperm are actually not going to survive. Inside of the walls of the seminiferous tubules, we have some cells that are called interstitial cells, and the interstitial cells are responsible for doing two things, okay? You have two different types of interstitial cells. You have ones that are called Leydig cells, and then you have ones that are called Sertoli cells. Leydig cells are directly responsible for producing testosterone, and Sertoli cells have been called nurse cells because what they do is they basically provide nutrients and support and protection to sperm as they are developing prior to getting basically put into, the lumen here. Here we go. So here is a cross section of a testy. Let me get black here. Black. Here we go. So here's a cross section of the testy. So as you can see, the testy sits outside, not up in the body, in the scrotum. Why? Because sperm production actually takes place, optimal sperm production actually takes place a few degrees below our homeostatic temperature. And speaking of that, if you look right here, there's a substance called the spermatic cord. And the spermatic cord holds a lot of stuff. So hopefully in here you can see that there are blood vessels, and you've got arteries, veins, and then that yellow would be a nerve here. But the anatomy of this actually very specific. So you can that you have an artery come in, but then you have kind of this network of veins coming out. So if you think about arterial blood versus venous blood, arterial blood is going to be warmer than venous blood. And so you have this venous blood that is coming out of the testy that is wrapping around the artery. And the wrapping of the veins actually is going to cool the arterial blood prior to it coming into the testes to also help with lowering the temperature of the testes for optimal sperm production. All right, so if we look down here, here is your testy. Here is that tunica albuginea that I talked about, and it is white, and it separates, as you can see, the testy into a bunch of lobules. And then inside the lobules, we have seminiferous tubules that, did I not lie? I didn't lie is what I'm saying. They look like ramen noodles. And inside of these ramen noodle looking things is where sperm production occurs, inside the seminiferous tubules. Once sperm are produced, they're pushed to basically the lumen. So remember, this whole thing is a tube system. So that means that we're dealing with structures that look like, this. Once sperm are produced here in the seminiferous tubules, they then move to the rete testis. The rete testis is where excess water is going to be removed to help concentrate seminal fluid. And then the sperm are going to move on to that thing that I told you kind of looked like a slug. That is the epididymis. Sperm are going to spend quite a long time moving through the epididymis, and this is where they're going to go through the process of sperm maturation or spermiogenesis. This is where sperm are going to wait to be ejaculated from. If for some reason ejaculation doesn't happen, sperm are going to be broken down and reabsorbed. The content is going to be reabsorbed. No harm will come to any male who does not ejaculate. I'm going to say that again. No harm will come to any male who does not ejaculate. We have some localized phagocytes that will just break down those sperm and recycle material. Once ejaculation occurs, then we have this ductus or vas deferens right here, okay? And then sperm are going to be pushed via peristalsis